The tooling, I can't say enough about the tooling. The tooling is the absolute enabling component to making a micro-molded part. I've estimated that it's about 85% of the way there. If you've got a correct tool, you have a correct part. And the reason for that is when you have specks of dust-sized parts, what you have in steel is what you have in plastic, because there's not a lot of shrinkage that you have to take into consideration, the polymetric shrinkage that you would with a larger part. It's steel to plastic, just about 1-to-1, even though you still have to apply the shrink to the model itself. So tooling, typically, you can't do this with conventional molds, but you can hold them in your hand. The inserts, cavity inserts, can be 1-inch diameter inserts, or they can be rectangular inserts. They can also be multiple cavity, but typically they're 2 to 4 cavity for very, very tiny parts. It's not uncommon to just see a 2 to 4. And when it's extremely small, which is the smallest I have been involved with, is 520 parts per plastic pellet. That's how small the molded part is. So you're actually splitting a pellet 520 times to make a part. The tool itself has to be made to at least 20% or less tolerance to actually make that part fill. So in the case of the smallest part in the world, it was actually a round part, and it didn't fill that 1.5 thou wall thickness. And what we found in steel was 2/10 in Y and 3/10 in X error, which if you think of that 3/10 in a conventional mold, you'd be probably pretty happy with that going out the door. But the 3/10 in relation to the 1.5 thou wall was 20% of the wall. So it was going to flow down the fat side and leave the thin side short. So what we had to do was actually make a new core to match that cavity, 2/10 and 3/10, and then actually make a D-shaped and key that in so that you were able to fill that wall thickness. So you're literally splitting tenths of thousandths of an inch to make a part fill, which is unconventional. You've got the picture that's you're 85% of the way there, but there are some other, certainly some other tricks here. Experienced problem solving in micro tooling and micro molding, micro computational analysis capability, a very highly robust tool, and a mold process design as well. Extremely precise micro molding machines. They are accurate to 1 micron positional accuracy, maybe even better at this point. But extremely accurate. And then there's ultra precise and customized resin drying systems. That's a key as well. But putting all those things together, these are pretty much the requirement to making micro molded parts.